Okay, now these are certain questions which can be asked, you know, in the exam. So if we am asking what is the least number which will leave a remainder r when divided by x, y, and z. So let me say the number is L. Before giving you the formula, I'll just tell you how you understand these kind of questions. So let me say my number is, first of all, whenever I have a least number, you might have a hint that it has something to do with LCM, right? But anyways, so let me take L as the least number. So he says when L is divided by x, my remainder is equal to r. So this means that if L is divided by x, it leaves a remainder of r. So if I have L minus r, then this will be completely divisible by x. This is a corollary. Similarly, he says L divided by y leaves a remainder of r. So again, L minus r is divisible by y. Similarly, L divided by z leaves a remainder of r. So means L minus r should be divisible by z. So this means that L minus r is divisible by all x, y, and z. This, and it is the least number. So this means simply that L minus r is equal to the LCM, because it is divisible by all these. So this means this is a multiple of x, this is a multiple of y, this is a multiple of z, and it is the least. So it is the least common multiple of these three numbers. So L minus r is the LCM of x, y, and z. So here is the formula that I get, that L is going to be equal to LCM of x, y, and z plus r. So this is my formula. So if I have to find out the least number leaving the remainder r when divided by x, y, and z, that is simply going to be LCM of x, y, and z plus this number r. But you know now how we have derived this. Okay, now let's take an example of this. So he says find the least number which when divided by 6, 7, 8, and 9 leaves the same remainder 1 in each case. So you can just pause this video and solve it yourself, but we just derived that in this case least number L is equal to LCM of 6, 7, 8, and 9 plus remainder is 1 plus 1. So LCM of, like I've mentioned here, LCM of 6, 7, 8, and 9 is equal to 504. So this means that 504 is divisible by 6, 7, 8, and 9. It is divisible by all of these. So if I add 1 to this, that is 505 will be the number which when divided by 6 will leave the remainder 1. And similarly by 7, 8, and 9, when you divide 505 by any of these four numbers, it will leave a remainder of 1. Okay, here's another very similar corollary to what we've just learned. If numbers n1, n2, n3, and n4, etc. give remainders r1, r2, r3, and r4 respectively when divided by the same number p, then p is the HCF of n1 minus r1, n2 minus r2, n3 minus r3, and n4 minus r4. So let me again try to simplify this for you. So let me say I have two numbers. I have numbers n1 and n2, and they are giving me remainders of r1 and r2 when I'm dividing them by p. So what does this mean? This means if n1 is divided by p, I get a remainder of r1. So this means that if I subtract the remainder, then this number is going to be divisible by p. So this is divisible by p. As you know, if on division by a number, if we get a remainder, if we subtract the remainder from the quotient, the remaining quotient will be divisible by the divisor. Similarly, n2 divided by p is leaving a remainder of r2. Again, so if I subtract r2 from n2, n2 minus r2 is divisible by p. So this means n1 minus r1 is also divisible by p, and n2 minus r2 is also divisible by p, which implies that p is a factor of n1 minus r1 and n2 minus r2. Now in the question, normally you will be asked the largest number. So which would make this to be P is the HCF of n1 minus r1 and n2 minus r2, and I can extrapolate this by whatever number of terms I can have. Let us say, let me add this one, n3 minus r3 and so on and so forth. So this is again the formula that I do get. So whenever you have a question like this, that when n1, n2, n3 etc. give remainders of r1, r2, r3 etc. when divided by p, then p is simply the HCF of the differences here. Now here's another example, which this is again very important. It is asked in the exams many times. So what is the least number when the differences between the remainders and divisors is constant? Let me first show you an example. So the question will be, find the smallest number which when divided by 5, 6 and 7 leaves the remainder 2, 3 and 4 respectively. In this case, you see that 5 minus 2 is equal to 3. Similarly, 6 minus 3 is again equal to 3. 7 minus 4 is equal to also 3. So this formula will apply whenever the divisors, yani this set, and the remainders, if I take the difference, I get the same number in all the cases. So if that is the case, then all I need to do is, if I am supposed to find the least number, that is simply equal to, all I need to do is take the LCM of these numbers 5, 6, 7. Obviously you can understand it's the least number which when divided by something, obviously it has to involve LCM, and you simply subtract the difference from here. So in this particular case, the LCM of 5, 6 and 7 is going to be basically 5 multiplied by 6 multiplied by 7, because there is no common factor. So LCM is just equal to the multiplication. So the LCM of 5, 6 and 7 will be simply equal to this, that is 210. Now I subtract 3 from this, I get 207, and this is my answer. You can check, when 207 is divided by 5, it will leave a remainder. This is the quotient, this is the divisor, this is the remainder. Remainder will be 2. Divided by 6, it will leave a remainder 3, and divided by 7, it will leave a remainder of 4. So whenever the difference between the divisors and the remainders is constant, you find out the LCM of the divisors and then subtract the difference. This is how you solve these questions.